So let me start. I mean, basically, with a question to all the panel. So basically in medicine, we're collecting more and more data, and sort of the expert becomes really the bottleneck. How can we scale them up?
I think one of the immediate approaches that we heard some of the other speakers about in the last panel is certainly crowdsourcing approaches. I know that's been very successful in our work at the Mount Sinai Health System, where we could deploy crowdsourcing platforms to get participation from all of the experts that we have access to. And then I think the other kind of immediate way is this idea that we've heard some of the speakers talk about as well, of weekly supervised learning, of trying to reduce the demand on experts to better utilize what's, sort of as you correctly point out, the kind of exhaustible and valuable resource for a lot of the medical efforts.
Yeah, I agree. I think crowdsourcing is a very powerful tool. If you can get a grip on the stratification of expertise within a typical group, everything from elementary school students up to PhD level experts, everyone has something to bring to the table. And I think what we found in the Visipedia work was that it benefited us to approach it in a way that we were not trying to design out the experts. This is not a design in, design out kind of endeavor. It was more that, I think as Eric indicated, expert time is precious. And in the case of birds, if you're showing thousands of rock pigeons to ornithologists, it gets a little bit boring, and it's not worth their time. So if you have some kind of stratified crowdsourcing system that can handle those with high reliability, you can actually save the really difficult, interesting, ambiguous stuff for the experts.
So I find what you just said really interesting. So how can we, are there strategies to simplify the tasks? I mean, I guess the sort of showing sort of multiple things and grouping them was an example in your talk.
Actually, just like for the birds, for example, like how did you go about stratifying them for your experts?
Yeah, so the Cornell lab already had a fairly well-developed educational program in place. So they had this idea of bird camp and quizzes and all sorts of skill assessment mechanisms. So we were able to build on that and basically have people take competency tests. And but there are lots of other tricks, as I'm sure you're familiar with, where you put golden examples into the data set or catch trials or things to try to throw off the crowd, and you can assess their skill in that way.
So I'd like to add a comment on this. So we are actually currently a little bit, we're struggling a little bit with the, let's say, to give an example of the summary generation work, right? So our system can generate summaries, right? The question is that how useful are they to a real user? And so what kind of, and we would like to use crowdsourcing for this kind of, so where we kind of show people alternative explanations and trying to rank them. But you can imagine that this is extreme. We have to kind of design the experiment itself, very carefully, because what are you actually trying to measure, right? So what are the, like, how do you, is this explanation better? And in some sense, right, the problem here is that if I don't know a person's, if it's like my personal data and I look at it, I can give a better feedback, right? So it's at least explaining my data to me. But if it's like a third person's data, on a crowdsourcing platform, and we're asking, is this really useful? It gets tricky when designing those kinds of experiments. So we've been sort of brainstorming with our IBM folks. They are in the behavioral health group there. And so we do intend to do something like that. We haven't done that yet, though. So just putting that out there.
Hi, this is Melissa Handel. Great talks, really interesting. I'm really interested, as you might imagine, in the intersection between some of your AI technologies and the use of ontologies and semantics. And from the semantics side, which is the part that I deliver, I'm curious about how can we build better semantics so that they can actually better inform the ways in which you're building your technologies, as well as helping maybe end users, and how can these resources be used together for end users, similar to the earlier question, in terms of like users trying to look at things that are similar, where it's knowledge that similarity that we're really trying to help identify in the context of a user interaction. And so the ontologies can support that quite well, whereas the machine learning and AI technologies can really sort of sift through the large, vast quantities of data. So how do we both build better ontologies at this intersection, and how do we build better UIs at this intersection?
So maybe I can take a first stab at that. So one way that I see where this can be very useful is, there's a lot of work recently on, let's say graph neural networks, right? So the idea is that you have not just, so you got data that has connections, right? So in this case, the connection would come from a knowledge graph, or actually the ontology, the concepts, the facts that support them. And the idea is to actually, if one way to merge the two worlds would be to actually create an embedding, right? Essentially, encode your knowledge graphs and your ontologies into a vector representation, right? So these embedding spaces, and then you just feed them in as another source of input to deep learning models or some other model. So that's one idea. So in a way, what you're doing there is you're relying on sort of the latent semantic understanding of these. So the hope is that your knowledge graph has enough of these connections that it can leverage that. But I think there's a little bit more interesting challenge there, which is all that is good for sort of localized learning, I would say, because your connections, but the kind of reasoning you would think a human would do could be much more non-localized, right? So you're kind of jumping from one concept to something else, and so how to encode that in a reasonable way is that's part of the research. I would say that that's one way to bring those two things together.
Mm.
Yep.
One thing I can comment on, because I work extensively with taxonomies and biodiversity. If you work with iNaturalist or Cornell Lab of O or hundreds of other publishers, they all have slightly different taxonomies. And they actually, next week, I'm attending a conference called the Taxonomic Data Working Group, TADWIG. And there are deep, historically seated reasons for why these taxonomies are different. And they certainly don't respond well to AI researchers just charging into the scene and saying, use this one or use this one. So instead, I think what Mohammed was talking about is very true in terms of the complementarity. On one hand, you have historically established taxonomies, and then you also have these raw features that can make an end run around all of that. But it doesn't mean one replaces the other. And what we notice is that if you take the case of birds, you have these strange cases where you might have an adolescent. Oh, I think it stopped working. Oh. You could have an adolescent female robin, and then you could have a mature male grosbeak, for example. And no self-respecting ornithologist would ever confuse those. But a K through 12 student might be on a hiking trip and see that and just consistently make that confusion. And so at the level of pixels, you can say, actually, these do look quite similar, but the sizes are very different or something like that. And so in terms of training the neural net, having access to a hierarchy is extremely useful because treating bird recognition as a 10,000 class problem without any notion of hierarchy is just very hard. But you need that ability to just jump out into a sort of folksonomy or some kind of sort of popular version of a taxonomy, and so that the users don't feel that they have to speak this very specific language. And when they see that, we notice that with the users, that they feel like it's meeting them on their terms, and then they get interested in learning the formal taxonomy.
I would absolutely love to talk to you about that more, but I do think that, well, first of all, there's a lot of strategies for how to harmonize the different taxonomies, and I talked about one of the ones that we've used yesterday, but I'd happy, and someone in my group is attending that meeting, so we can,
oh, cool.
We can follow up. But the other thing is just, I think being able to put names, and we talked about this yesterday too, being able to put names on clusters of things that don't necessarily have names already, and kind of being able to kind of post-compose those sorts of things on the fly. I think that's something that could really help the UI question as well, which really gets at what you were saying. So thank you.
My question is for Dr. Zaki. So I found it interesting in comparing what you were saying to the keynote speaker in the beginning. You know, he was working on training robots, and they listen when you tell them something, and humans don't always listen. And I was thinking about those sort of summary statements, and how, say you've got a patient, they're trying to lose weight, they're on this plan, and they stick really well to their plan, and it comes up and it says, every single time you ever had a week like this, you did worse the next week, right? Like, your emotions aren't going to say, oh, I had a really good week. Your emotions are going to be like, that sucks.
Yeah.
Like, so how do you kind of incorporate are you like working with psychologists, or how do you bring that kind of emotional side of trying to train a human into?
So that's an excellent question. So in fact, I didn't really talk about that, but we do have a stream of work within our group where we are working on the behavioral aspects of, you know, exactly what you're saying. So how do you actually sustain behavior? So this is a manifestation of that same issue, right? That is, either you might get discouraged, right? So, you know, oh, it's nothing working, you know, I tried this, and, you know, next week I kind of just totally blew it. Or it's just that, you know, you might be super good for, you know, a month, and then you might lax, you know, so the idea that how do you keep people motivated throughout this? And so the work we've been doing is we ran a pilot study this past summer where we just wanted to see what kind of incentives, right, would help people kind of maintain a goal. And the goal here was to just walk, you know, 10,000 steps a day and, you know, keep their activity level high. And so we had these, you know, we recruited about 160 students, you know, from RPI and SUNY Albany, and we kind of, you know, we did a sort of a classic design. So the results are not out yet because the data is still being analyzed, but the idea was that we had, you know, basically 4 groups, right? So there's a control group that did not get any notifications. The second group got a little bit of, you know, just some guidelines saying that you try to maintain, you know, healthy behavior. A third group actually got some encouraging, you know, feedbacks. And then the fourth group also got some incentives in terms of, you know, rewards and some, you know, things like that. So we are looking at those things, and I believe that, you know, it's a lot of exciting work to be done in that. But I haven't got any conclusions that I can share with you, you know, right away.
Thank you for a very interesting talk. Gabriel Evgerinos from Energy and Wellness. The question is for you, Mohammed, again, about the food KG. I think in some of the slides that you had to go quickly through, have you included, as part of these pilot tests that you're currently doing, the types of exercise and the data collected through wearables that would help metabolize the various nutrition ingredients that people are getting, especially in cases of pre-diabetics, to be able to control, for example, carbs conversion or sugars conversion to A1C, et cetera. And to what extent has that kind of data been, is it available or is it still being analyzed? Thank you.
Actually, unfortunately, we haven't begun that part yet. So our goal, our grand vision, right, is to do food, which we have the food KG now. The second goal is to do this personal KG that I mentioned. And actually, the third one is the diet KG, which we haven't yet begun on that. So we said, let's just do this in phases. And so unfortunately, I don't have a response for you that, so there is, I am aware of, you know, certain, so we've done some, you know, background work on this. So there are certain studies, you know, so they've done these knowledge graphs for health, meaning in this case, physical activity. So I do have some references that I can point you to if you are interested.
That would be terrific.
Yeah.
Just for clarification, when you say food, in this day and age, a lot of people are consuming things that normally you wouldn't consider food, might even consider as supplements. Mm-hmm. So things like gojis, for example.
Oh, yeah.
Things that have a direct impact, anecdotally, on people's health in other countries and are now consumed in very large quantities, and the FDA is staying as far away as possible from that area. Are you including those as part of the food study, or is that a separate?
Right now, the focus was on the recipe side of things, right? So I think it's, we can expand this even much more because, once you start actually linking the full food ontology, then you get into all the other, alternatives and, health supplements and this and that. But we haven't done that yet, no.
Thank you.
I'm Noelle Langen. I'm actually a clinical cardiologist, EP, so we have a lot of data coming in. I'm quote-unquote director of operations, which means I'm the one that sees the most patients and tries to keep them organized and try to make Epic usable. So listening to you, first of all, thank you very much, is very, very fascinating. But one of my great interests is how do you get the clinician expert, which a clinical electrophysiologist is we have a very, very high level clinical EP. How do you capture the expertise of these great physicians in AI, use AI? And of course, you're all talking about that. What comes to mind from hearing all your conversations is the problem of goal. When I'm in front of a patient, first of all, I have physician assistants who have built what your AI is going to do for me. And my goal is to make sure I accentuate the proper goals, which are often in conflict. So the guidelines, and this is what I teach the students, the guidelines are only your beginning because there are multiple guidelines that are disagreeing, and I'm sure you're all aware and dealing with all of that. But it's interesting how many of these talks are about one goal, so the person has to stand up. But of course, there's multiple conflicting goals when it comes to humans and when it comes to nutrition too. For example, am I satisfying my girlfriend when I'm a guy who just cooked me a meal and I want to marry her? I have to make sure she thinks I'm a good cook. She's a good cook or whatever. I mean, this is all very old-fashioned what I'm saying. Is it a family occasion? There are multiple goals in that week. Or in my case, do I work on my patient or do I work on building the projects that I'm working on? So there are multiple conflicting goals at all times. And as a physician, you're the trusted one to be balancing those goals for that person. So that's where the personalization comes in. And I know there's this whole paternalistic combination, but it's actually very, very complex and very quick decisions that are made about that. So I just wanted a feel of how you put these multiple goals into these equations that you guys are talking about, or conflicting goals.
You can all have a quick comment on this one.
So my comment is, this is related to a pretty active area in machine learning known as metric learning, and there's something called disentangling in metric learning. And what it means is that there's no single way that two cases are the same. So when I showed examples of birds, you could just ask someone, how similar are these birds? But for someone who really knows that domain, they'd say, what do you mean? There's so many criteria by which I could evaluate that. And so if you fine-tune the questions and you set it up in a kind of interrogative way, you can say, like in your case, here's one patient, here's another patient. You have such a vast repository of experience, and you can say, well, this reminds me of this patient. Oh, in what way? Well, this patient is similar to this one, however, this person was a different age, demographic, something. So I think in the beginning, a lot of the metric learning work was just monolithic, and now machine learning researchers are much more interested in disentangling all those factors, and the only way to get at that is by working with experts. I don't have the solutions, but that's where you would find that kind of thing.
Eric?
I'll just kind of echo what Serge said, that certainly this is where the domain expertise really becomes a large part of the equation. Definitely, when tackling any of these problems, all our current approaches work on the narrower the problem, so the better we're able to build solutions against. And I think where domain expertise really kind of enters into this is both in finding the most narrow problems, or the way of narrowing the problem to the most kind of simplest question we can ask of a computational system, or if that's not the case, of finding the ways to start defining how these systems might interact together.
Okay.
This ends the panel discussion. Let's have a round of applause for our panelists. And